Today's math lesson is on formulas. We're starting a new unit in algebra and patterns. So we'll start with formulas. It's a bit of a longer lesson. You're going from pages 77 to 80. A formula is an equation for a specific pattern. If we were to look at each of the diagrams, we would see a square and some triangles. So if we look at the first when there's one square, we have 1, 2, 3, 4, 5, 6 triangles. So we would put 1 in the squares column and 6 in the triangles column. When we look at the next figure, it has 2 squares and it has 3, 6, 9, 12 triangles. Finally, if we look at our last figure, we have 3 squares, and there are 3, 6, 9, 12, 15, 18 triangles. Now, the step that we're going to be adding is in the middle, you will have a formula or an equation that will let you go from squares to triangles. So we're starting with squares and we're going to end up with triangles. So we see, how do we get from 1 to 6, 2 to 12, and 3 to 18? One of the first things that I actually do is look at how much does the pattern go up by each time. So we're adding 6 each time, which usually means that's what we'll multiply. So we can check if we go 1 times 6 is 6, 2 times 6 is 12. 3 times 6 is 18. So then that is our formula, and that should work for each of these. We multiply by 6 each time. For question 1, they're going to give you a chart and you will need to fill in the rest of it. So they will give you your squares, they will give you a formula, and they'll have a column for triangles. So your job is to fill it out. So if we look at this formula, 4 times squares equals triangles. So for each of these, we're going to have the parts that are not the variables will stay the same. So it'll always go 4 times something equals something. Then you look and fill in the variables that match. So if this is S, then for this column we put in our S value, which is the number of squares. So we would put 4 times 1. I don't know why that is so large. 4 times 1 equals 4. So there would be 4 triangles. Here in our space where S goes, we're going to put 2 because that's the number of squares. So 4 times 2 is 8. So we would have 8 triangles. Then if we look at our number of squares in our third row, we have 3. So it'd be 4 times 3 is 12. So 12 would be our number of triangles. Now, one thing you'll have to watch for some of these examples is that they might change the number of squares. They might not all be 1, 2, 3. So you'll need to pay attention to that. So if we look at our formula, we can start again by putting in everything that's not a variable. So it'll always be 3 times something equals something. So 3 times the number of squares equals triangles. And if we look at this first one here, our squares are 8. So 3 times 8 is 24. So there are 24 triangles. The next one, 3 times 12 squares equals 36, so there would be 36 triangles. And finally, 3 times 16, which I believe is going to give us 48. So there would be 48 triangles for that one. So just make sure you're looking at the information they have in squares. For question 2, they're going to ask you to write a formula for a T-chart. So they'll give you the number of squares and the number of triangles. So 1 square is 7 triangles, 2 squares is 14 triangles, 3 squares is 21. So you might automatically notice that if you take the number of squares and you multiply it by 7, it equals the number of triangles. So that would be your formula. If you were getting a little bit stuck on that, I also find it helpful to look at the triangles and figure out how much is it going up by. Well, it's going up by 7 each time, so that is what we would multiply by. Question 3 is talking about geometric patterns made out of squares, rectangles, and triangles. For question 3, there will be several different shapes that they are making, or figures, out of squares, triangles, and rectangles. So I've just drawn by hand one example. This is a bit different than all the ones in your book. And they're going to get you to figure out, if there's one square, how many triangles are there? So with one square, there's 1, 2, 3, 4 triangles. So that's what I would put under the triangles. Now, if there were 2 squares, then I would have twice as many triangles. So I would have 8 triangles. And if I had 3 squares, then I would have 3 times as many. So I would have 12 triangles. So the first step is to fill out this chart. The next step is to decide the formula. So for our formulas, just like on the last questions, we'll most likely have kind of our squares times something equals the number of triangles. So if we were to look at our chart, we would see that, okay, how do you get from 1 to 4? Well, you times it by 4. How do you get from 2 to 8? Times 4. 3 to 12 times 4, which also coincides with how much it's going up by each time. So your formula could be S times 4 equals T. If you write it the opposite direction, 4 times S equals T, that is the same thing. They are both correct answers. Because of the commutative property with multiplication, it doesn't matter which number we put first. It's only subtraction and division that matters. Question 4 asks us, how many rectangles will Wendy need to make a design with 7 squares? So I'm just going to be making up numbers here. These are not the numbers for 3A from your question. So I am using different numbers. So I've just kind of made them up. For every square, there are 3 rectangles. So for this formula, if we wanted to figure out our squares times what equals the number of rectangles, well, it would be times 3. So you have 2 options. To figure out how many rectangles they need for 7 squares, you could either go, okay, squares equals 7, so 7 times 3 equals 21. So you would need 21 rectangles, or you could continue filling in the chart until you get to 7. And then you could go, okay, well, 3, 6, 9, 12, 15, 18, 21. Either way, it will give you the same answer. So remember to use the numbers for 3A, not the numbers that I have used here. Question 5 tells you that there are 39 triangles, and they're wanting to know if you have enough triangles to make 7 copies of this shape. So you have a couple options here of how you can solve it. You can either make your chart of squares to triangles, and you can fill it in to go up to 7 copies. So then if this number on the side is 39 or less, you would have enough. And if it is more than 39, you would not have enough. The other thing you could do is you could come up with a formula. So if you had your formula and you figured out that S times something equals your triangles, then you could put in 7 times however many you need to get to your triangles. If it gives you an answer that is less than 39 or 39, you have enough. If it's more than 39, then you don't. Number 6 is going to ask you to create a design using squares and triangles for the corresponding formula. So for example, if they gave you 4 times squares equals triangles, then you would know that for every 1 square you have 4 triangles. For 2 squares you have 8. So you would just need to come up with some sort of design that has 1 square and 4 triangles, and they could face any direction you like. They don't even have to all be symmetrical. For number 7, they're asking you to create a design of squares and triangles and then write a formula for your design. So this is kind of putting all of these steps together. So these will be my infamous instructions. You're putting together everything you've already learned. So use your brain, come up with a creative design, squares and triangles, and then figure out what would your chart look like, how would you write a formula for that. As we're looking at exercise 8, instead of having our diagrams of shapes and designs, we're going to be looking at kind of rows of chairs. So they'll give us a diagram that has the row, which is represented by R. We'll have a formula in the middle, and then we'll end with our number of chairs, which is represented by C. So if we were to fill in this chart, in row 1, we have 1, 2, 3, 4, 5 chairs. In row 2, we have 6 chairs, and in row 3, we have 7 chairs. Now, this is going up by 1 each time. So it's not the same thing where we can go 1 times 5 is 5, 2 times 5 is not 6. Instead, we're going to have an adding formula where if we take the number for our row, so our row number is 1, and we add 4, we get the number of chairs, right? 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. So we're going to be looking at formulas that have addition instead of formulas that have multiplication. So if we look at our chart, I'll give you an example here. Once again, we're going to copy down everything that is not a variable. So we know that everything will be your row plus 3 equals the number of chairs. So for example, 1 plus 3 is 4, so our number of chairs is 4. 2 plus 3, because our number of rows is 2 now, is 5. So our number of chairs in the second row is 5. And then we would have third row is 3 plus 3 is 6. So there would be 6 chairs. For number 9, they're going to give you a chart that has rows and chairs, and your job is to come up with the formula. So when we're looking at this, we have to go from 1 to 5, 2 to 6, 3 to 7. So because they're just going up by 1, this is probably going to be an addition formula. So we know our row plus something equals our chair. And if we look at each of these, 1 plus what is 5? 1 plus 4. 2 plus what is 6? Plus 4. 3 plus what is 7? Plus 4. So we would just put Question 10 is going to just give you a diagram of rows and chairs and arrangements and then ask you to fill in your chart. So we've got row 1, row 2, and row 3. And in row 1 there are 1, 2, 3 chairs. Row 2 has 4 chairs, and row 3 has 5 chairs. So then we need to come up with our formula. So rows plus something equals chairs. And how do we get to it? 1 plus 2, 2 plus 2, 3 plus 2. So we're going to add 2. So our formula is r plus 2 equals c. Question 11 is going to ask you how many chairs will be in the 10th row. So you'll have different numbers, but if I looked at my example for question 10, I would go, okay, well, my formula is r plus 2 equals c. So if I said that this is the 10th row, I'm going to replace that with the r. So I would go 10 plus 2 equals 12. So there would be 12 chairs in the 10th row. For number 12, they are going to start by giving you an input and an output chart. So instead of having like rows and chairs or squares and triangles, we're going to have our input, the number that we put in, and our output is the number that comes out. It's almost like an imaginary input-output machine. So they're going to give you a rule. So for this one, we add 4 to each input number. So we go, okay, 0 is our input. So 0 plus 4 is 4. So that will become our output number. Now our next input is 1. Well, 1, add 4. So 1 plus 4 is 5. That's our new output number. 2, we add 4, so that gives us 6. So you're just following the rules. A few things to watch out for are that the inputs can change. So in this one, your input numbers were 0, 1, and 2. For some of your examples, they will be 4, 5, 6, or 15, 19, and 23. So you'll have to make sure that you are adjusting for those differences in numbers. They will also change the operations. So they might ask you, instead of just adding, you might add, you might subtract, you might multiply, or you might divide. So always start with the input, do the operation, then go to the output. Now, the other example I'm going to give you is with a formula. With a formula, they might give you something that looks more like a math sentence, like input divided by 2 equals the output. So if they've also told me that my input is 26, 14, and 6, then for my output, I would have to be going, okay, well, 26 divided by 2 equals 13. So my output for that one is 13. Oh, my number's changing. 14 divided by 2 is 7. And then 6 divided by 2 is 3. So this will be a different format. We've got our rules that are in words, and our formulas still have words in them, but they tend to more focus on symbols. So you wouldn't say divided by, you would just use the division symbol. The last question for question 13 will give you an input-output chart that's filled in, and your job is to fill out the rule. So remember, for some of them it will say rule and some will say formula. So if we hear a rule, we're going to put it in words. So if we're going from 15 to 3, 10 to 2, and 25 to 5, we have to figure out, is this going to be multiplication and division, or is this going to be adding and subtracting? So if you look, you go, okay, well, 15 to 3 could be divided by 5, or it could be minus 12. 10 to 2 could be divided by 5, or it could be minus 8. 25 to 5 could be divided by 5, or it could be minus 20. Now, the one that's the same in all of them is going to be your rule, right? So your rule would be divide the input by 5. So once again, if we have two sets of numbers, we can see how to connect them. So 27 to get to 9, I could divide it by 3, or I could subtract 18. To get from 21 to 3, well, I could divide it by 7, or I could subtract 18. And to get from 24 to 6, I could divide it by 4, 6, 12, 18, 24, or I could subtract 18. Well, this is the only one that's the same. So my formula or my rule needs to be subtract 18 from the input number. The second set of questions will give you an input-output chart, just like we've got here, but instead of asking you to write a rule, they'll get you to write a formula. So we're just going to practice changing these rules into formulas so that you're used to what the difference is, and then you should be good to go for your lesson. So divide the input number by 5. Well, our formula would be input divided by 5 equals output. And if they're asking us to subtract 18 from the input, then we'll have our input minus 18 equals our output. So the only difference between the first 3 questions in 13 and the second 3 is that one is asking you to write it as a rule, and the next one is asking you to write it as a formula. So just a quick review. Rules are in words, and formulas use math symbols. So you'd have like the division, multiplication, addition, and subtraction signs. So this is the end of your lesson. Go ahead and get started. It's a bit of a longer set of pages, but you should be okay. Make sure to let me know on FreshGrade in a comment when you are finished and if you need any help.